All right, so if I take a look at my first one, I'm going to choose, and I don't choose x as my inner function because that makes no sense. So what I'm going to do is I'm going to choose this entire value underneath the radical as my inner function. So I'm going to let g of x equal x cubed, or x squared, minus 8. That means my outer function must be the square root. So f of x must be the square root of x. Oh, cube root. I knew there was a cube somewhere. All right. On my next one, I'm going to let my g of x equal x cubed. That means my f of x is going to be x over x minus 1. Now you may have done it slightly different, and that's totally cool. My next one, I'm going to let g of x equal x minus 1. That means my f of x must be x squared, 2x squared, minus 5x plus 7. So you have to recognize who the inner function is and who the outer function is, and sometimes we're going to decompose it 4 times. That could happen, and all of its joy and fun. So if I were to try to find a polynomial where I have x minus 5 to the 6th, there's no way I'm going to multiply that baby out. It's just not going to happen. It's just not going to happen. Nor am I going to take the sine to the 4th, 3x, and use my identities in trig. I'm not doing it. What I have is I have the chain rule, and that's what we're going to learn now, is the chain rule. The chain rule says I determine who my inner function is. My inner function, g of x. First I do the derivative of the outer function, and then I do the derivative of the inner function, and I multiply those two values together. So notice you can also use it as u. dy dx is the derivative with respect to u, and then u with respect to x. So in other words, take the derivative of the outer function, multiply it by the derivative of the inner function, and keep going until you're the most inner function and you're done. So if I go back to my first 2 examples where I had f of x is equal to x minus 5 raised to the 6th, f prime of x is going to be the derivative of x to the 6th. If I want to think of the outer function as being x to the 6th. So it will be the derivative, if my inner function is x minus 5 and my outer function is x to the 6th, then I'm going to do the derivative of my outer function first. So it is going to be 6 to the 5th power. Notice I just left a blank there because I really need to put that function back. And I multiply the derivative of my inner function, which just happens to be 1. And I did not have to multiply that baby out, which is awesome. If I look at my second one, y is equal to the sine of the 4th, 3x. I'm just going to rewrite this as y is equal to the sine of 3x raised to the 4th power. Now this is a triple one. My most inner function, r of x, is 3x. That's my most inner function. My function expanding out, g of x, is the sine of x. My most outer function is x to the 4th. So the derivative of this, y prime, is going to be the derivative of my most outer function. That 4 is going to come down, and then I drop it down a power. So it's 4 to the, and that goes to the third power. Notice how I left that a blank because I need to put back my sine 3x in there. So the sine of 3x needs to go back there. Then I need to do the derivative of sine x. Well, what's the derivative of sine x? So it's cosine of, well, notice how I left a blank there because I need to put that 3x back in there. And then I need to do the derivative of 3x. What's the derivative of 3x? So my final answer is 12 cosine 3x sine cubed 3x. And that's the chain rule, and I had to do it 3 times to get to my most inner function. I'll stop, give you an opportunity to read through it, write it down, and ask questions. So I'm going to stop right here. So if you let u equal g of x, then y is equal to f of g of x. So y equals f of u. I wait for that all year until I get to say fu. All year.
To math or
to math? All year. All right. Now, if you're doing the power rule, I just showed you how to do the power rule. You can write down the definition if you want. The best way to get good at these is lots of practice. Really, the only way to get good at these is a lot of practice. So there's the definition. So if you're writing your formula sheet, you can write that on there if you like, or not. Just want to practice, that's okay too. Don't forget to see your advisors tomorrow. Don't just take the day off just because. If you have other things you want to do, go see your advisor in the morning, then go do your other things. So here's when you're using the chain rule with trig functions. Please don't write all these down because holy moly. Basically, what you do is you do the derivative of your outer function, which is, if it's cosine, you do the derivative, or sine. If your outer function is sine, it is going to be the cosine of your angle times the derivative of your angle. If you're doing the cotangent of an angle, it's going to be cosecant squared of the angle multiplied by the derivative of the angle. So please don't write all those down. Somewhere you should have just your sine and cosine. You should have your trig functions. Already wrote down somewhere. So here you go. Go ahead and use the chain rule on these. Start with a small. Start with the first 3. Please do the derivatives of these using the chain rule and everything that you've learned so far. Decide who your inner function is. Decide who your outer function is, and you may have to go in twice. I'll come around and help. So on the first one, who's my inner function? Yep, who's my inner function? What's the derivative of that?
3x squared.
Who's my outer function?
X to the 5th.
What would be the derivative of that?
5x to the 4th.
But is it really just x by itself, though? No. So really what we have is that this is going to equal to the 5, my x is really x cubed plus 3 to the 4th. Okay? That is my outer function derivative. My inner function derivative is 3x squared. So my final answer is going to be 15x squared, x cubed plus 3 raised to the 4th power. How was that? Cool? Going on to the next one. So you all want to go to Calc 2 because the worst part's over. It is. So who's my inner function? We'll start with the inner function first. Who's my inner function? 5x squared plus 3. What's the derivative of my inner function? 10x. What is my outer function?
X to the fourth.
What is the derivative of x to the fourth?
4x to the third.
But do I just write x there, though? I need a 4 right there. Do I just write x? Nope. So this is the derivative of this, should put an arrow though, that is y prime is equal to. So y prime is going to be equal to 4, my inner function, 5x squared plus 3 to the third power. And then multiplied by my outer function, or my inner function derivative, which is 4x, no, it's 10x. 10x. So my final answer is 40x, 5x squared plus 3 cubed. How are we doing? Not too bad, I hope. Cool. Chain rule is your friend. It is so much your friend. All right, who's my inner function on this? What's my derivative of my inner function? What is my outer function? Is it okay if I write it like that? X raised to the 1/4? What is the derivative of that? Okay. So my derivative, f of x, f prime of x, is going to be 1/4. And then do I write x raised to the negative 3/4? Nope, it is my inner function raised to the negative 3/4. So it is negative 3x to the 4th minus 2 raised to the negative 3/4. And then the derivative of my inner function, which is negative 12x cubed. Rearranging it, I'm going to put negative 12 over 4, which reduces to negative 3. And then x to the third. And then I'm just going to write my exponent positive, which means I'm going to just bring that down in the denominator. And so it's going to be 3x to the 4th minus 2 raised to the positive 3/4, just to make my exponent positive. And you'll notice on web work, it really wants positive exponents everywhere. So if you're getting something incorrect, it's probably because it wanted you to write it as positive exponents. How was that? Any questions on what I did? I see some furrowed brows. Is there questions? Yes.
Is that 3 in the denominator supposed to be negative?
In the denominator?
3x to the 4th.
Oh, yep. Thank you. Negative 3x to the 4th. Anything else on that one? How are we doing? Okay, here's some more to do, because I'd hate, oh, we'll just have one and then we have a space. So go ahead and try that one. So my inner function is negative x to the 4th minus 3. My derivative of my inner function is negative 4x to the 3rd. My outer function is going to be x raised to the negative 2. The derivative of my outer function is negative 2x to the negative 3. Now bringing this together, y prime is going to be negative 2. I replace x with my inner function. So minus x to the 4th minus 3 raised to the negative 3, multiplied by my inner function derivative, which is negative 4x to the 3rd. Cleaning this up algebraically, I have a negative 2 multiplied by a negative 4, which gives me a positive 8, x to the 3rd. And then I'm just going to write that down in the denominator to make it a positive exponent. So negative x to the 4th minus 3 raised to the negative 3, a positive 3. How are we doing? Chain rule? Love it, hate it, you depend. It depends on how you look at it. Oh look, here we go. Here's more fun and joy. If you don't like the quotient rule and you understand the product rule and the chain rule, you can rewrite this as x to the 3rd plus 4 raised to the 5th power multiplied by 3x to the 4th minus 2 raised to the negative 1. So if you don't like the quotient rule, you can just strictly use the product rule and the chain rule. All right, so if you're doing this as the product rule, this is how you would write the function. The product rule, remember, is going to be u prime v plus v prime u. If you let this equal u and you let this equal v, then the first thing you have to do is the derivative of the first piece. Using the chain rule, the derivative of the first piece, u, is going to be 5 x cubed plus 4, dropping this down a power, times the derivative of that inner function, which happens to be 3x squared. All of that I just wrote is u prime. Now I have to multiply it by v, which is 3x to the 4th minus 2 raised to the negative 1. That is v. Now I have to do the derivative of v prime times u. So plus, the derivative of v is going to be a negative 1 is going to come down out front, so minus 1. 3x to the 4th minus 2 raised to the negative 2, I drop at a power, multiplied by the inner function. The inner function is going to be 3 times 4, which is 12, x to the 3rd. All of that represents v prime. Not u, that looks like a u. V prime. And I multiply it by u, which was x to the 3rd plus 4 raised to the 5th power. Okay? Since we're running short on time, I'm not going to clean it up algebraically, but that's what the derivative would look like without the cleanup. On this next one, I have a function inside of a function. So I'm going to think of this as u to the 5th minus 1 raised to the 4th power. That's how I'm going to think of it. That's how I'm going to think of this. So if I'm asked to do the derivative y prime, first I'm going to do the derivative of my outer function. So that 4 is going to come back down. And then I'm going to have x plus 5 raised to the 5th power minus 1 raised to the 3rd power. That is just the derivative of the outer function. Now I'm going to do the derivative of my inner function. My inner function is u to the 5th minus 1. So this is going to be 5 x plus 5 raised to the 4th power. It's my u prime. And then I need to go even further in. Well, my further one in is just linear, so it's just multiplied by 1, so I don't have to worry about that one. How was that? Cool. Taking a look at my next one, I'm going to do the product rule again. This is u. This is v. So y prime is equal to the derivative of my first function. So it's going to be 5x to the 3rd minus 3 raised to the 4th power. That's my outer function. Now I'm going to multiply it by my inner function, which is going to be the derivative of my inner function is going to be 3 times 5, which is 15x squared. I now need to multiply that by, all that I just wrote there is just u prime. And I'm going to multiply that by v. My v is the 4th root of negative 4x to the 5th minus 3. Now, if you've been paying attention, check this out. And this one here. I already did all of them, but it's all cool. It's all cool. Let's keep moving. So plus the derivative of my second one, I'm going to start with my inner function, or my outer function. It's going to be the 4th root of negative 4x to the 5th minus 3 raised to the negative 3/4. It's the derivative of my outer function. My inner function is going to be minus 20x to the 4th. That all represents v prime. Now I just have to multiply that by u, which is 5x to the third minus 3 raised to the 5th power. And then I'd algebraically clean that up as well. How are we doing? We like the chain rule? We hate the chain rule? The chain rule is the best thing we've ever seen in our lives? Well, just think of how much joy and fun you would have if you actually had to use the rules of trig, all those identities to do some of this stuff. That would suck. I mean, that'd be great. Be the best thing you've ever done in your entire lives. All right, we want to go to, which one do we want to do? I think we want to jump to F. Please do, or I, jump to I. Okay, so F prime, 3 the sine of x to the 5th raised to the 2 power. That is your outermost function. Now I'm going to do the derivative of sine x to the 5th, so that's going to be multiplied by cosine of x to the 5th. It's like my middle function, like Middle Earth. And then the innermost function is going to be x to the 5th, so that's 5x to the 4th. How is that? We good? Cool. All right, so now we're going to start doing second and third derivatives. We're going to start with the second derivative. Which one of these would you like me to do? C. Cool. Y prime is equal to, I'm going to rewrite, first of all, I'm going to rewrite y as equal to the sine of the cosine of 2x raised to the 5th power. That's the first thing I'm going to do. So then y prime is going to be equal to 5, the sine of the cosine of 2x raised to the 4th power. That's my most outer function. The next function in is sine. So I'm going to do the derivative of sine, which is going to be the cosine of 2x. And I'm going to keep going in. Inside of that is the cosine, so I'm going to do the derivative of cosine, which is negative sine of 2x. I'm going to go to my most inner function, which happens to be 2x, so it's 2. And there it is in all of its glory. And then I do it again because I want the second derivative, but unfortunately I'm running out of time. So let's take a look at the example here. Determine that the equations of the lines tangent to the graph y is equal to this are at the points this and this. How do you think I'm going to attack this one? How do you think I'm going to go about doing this one? Determine the equations of the lines tangent. Yep, so I'm going to use the fact that I've got y is equal to mx plus b. Do I have a y value? Sure. Do I have an x value? Sure. Can I find the b from those two? Almost. What do I need to find? How do I find the slope? Take the derivative all day long. Y prime is equal to, I'm going to have the derivative of my first one, which is 1, multiplied by my second one, which is 5 minus x squared. And then plus the derivative of my second one, this is the chain rule, so it's going to be 1/2 5 minus x squared raised to the negative 1/2, multiplied by my inner function, which is 2x, and it should be a negative 2x, multiplied by my first function, which is x. And there's the derivative, which is the slope of the tangent anywhere along that curve.
Like you're saying, for understanding the 5 minus x squared raised to, or just.
Yep, thank you. Put that squared in there, thank you. So it is, again, it is the derivative of u, so there's u prime, and this is v, so here's u, This is V, and this is V prime. Just so you know where each piece came from. Okay, almost out of time. So read through this one, and then tell me how I would approach this one, and then we're done with this section. We put it to bed. Well, you have the homework you have to do.
Can you scroll up just a little bit so we can go to the last problem?
So assume f is a differentiable function whose graph passes through the point 1, 4. If g of x is equal to f of x squared, and the tangent line of the graph is at 1, 4, y is 3x minus 1. Determine each of the following. How would I do that? How would I do that? Well, I know that g prime of x is going to be the derivative of x multiplied by the derivative of the inner function, because it's a composition of functions. Okay? If I go through the point 1, 4, here, I go through the point, f is assumed, and the tangent line at the graph 1, 4. So I know I'm going to go through the point 1, 4. So I know what my x value is, and I know what my y value is. Do I know my tangent line? Do I know my tangent line? Do I know my tangent line? Yes, I know my tangent line. So what is my slope? 3. So this thing has to equal 3, right? Do I know what my x is? 1. I'll leave you with that. Have a great day.